this video, I'll be doing a detailed solution to the maths question you see on the screen here from the 2024 Cambridge A-Level mechanics paper, specifically paper 4.1. If you're looking for a different question from this paper, or a different paper entirely, check out the description below for links. And if you find this video or any of the videos on my channel useful and you want to help the channel out, what helps the most is sharing this video, especially if you're in a class group with other people sitting the exam. Also, I do appreciate likes, subscribes, or even a super thanks. In question 1, we're given some numbers for the motion of a car, and we're asked to draw a graph of it. That's a velocity by time graph. So time down the bottom here, velocity up the top. Now, when we're sketching a graph, we only want the important numbers. It doesn't have to be, doesn't have to look too good. Our scales don't have to be perfect. We just have to get all the important information on it there. If you don't like that, I do recommend drawing the graph in the working space first, and then putting your full marks, your full answer on the thing. I'll show you what I mean by some mistakes in scaling that I'll purposely make here. Okay, so the information they tell us, a car starts at rest and accelerates at 2 meters per second. So that's at rest, it starts in the world at time 0, and at rest is 0, so that's our first point for the car. It accelerates at 2 meters per second for 10 seconds. Go over some number here, 10. I'm not measuring anything here, I'm just guessing a number 10. And it accelerates. Acceleration is a straight line up. And we get up to a certain height here. On a sketch, you do want to have all the important information. So I would like to know what this number is. We can use our units, our equations of motion. Like we know the initial velocity is 0, final velocity is, we're looking for that. Acceleration is 2, time passed is 10, and we don't know distance either. But that's enough information. We can find the final velocity with equations of motion. The final velocity would be, well, the initial velocity, in this case is 0, so it doesn't really matter, plus just acceleration times time. And really, you could have just said acceleration times time because we're starting from 0 here. And that'd be 2 times 10, so 20 here. And you don't need this 10 and 20 to match up or anything, just want the important numbers. Okay, next thing they tell us is it travels a constant speed for 30 seconds. Constant speed means it doesn't go up, it doesn't go down, it just goes in a straight line. Oh. Okay, a straighter line than that maybe. And it goes for 30 seconds, 30 more seconds. So 10 goes up to 40 here. And so this is still at 20 here. And then finally they tell us it uniformly decelerates, goes down over a period of 20 seconds. So 40, get all the way up to 60. If you run out of room here, just extend your line on. It doesn't matter. Again, if you're worried about that, do it roughly first and then come back with a ruler and get your measure out better spaces. But that's not important in a sketch. Okay, sorry, decelerates from here down there. That's full marks. Even though my scaling is terrible, even though my lines are a bit wonky, this gets all the information you need across. If you need to be neater yourself, that's fine. Like I said, just spend an extra minute ruling out and measuring things out. Okay, let me move on to part B. In part B, they ask us to find the total distance travelled by the car. Now, there's 2 obvious ways I see to do this. One, the way they want you to do it, but that requires you to know something a little extra. It's something you should know, you're doing the exam after all. That requires you to know that the distance is the area under this graph. It's something you should know, it's a famous enough thing. So really, the first way to answer this question is just find the area under this. That means find the area of this shape here. No, that's not too bad. I'll do this first and then I'll do it another way, because a lot of students would forget this. So I will do it another way in a moment. It's a bit longer. So the area of the shape, we need the length down the bottom, that's 60. That's the total time. We need the length on the top part here. These are 2 parallel lines, that's important. That's 30, that was here. And we need a perpendicular height, that's 20. So this is, I can't remember what the shape's called, I'm afraid. But there's a formula for it. It's half times these two lengths, that's 60 plus 30, times the height, 20. Or of course you could just break it up into a triangle, because you know this length here, you know the height, another triangle, you know this length, this height, and a rectangle. So you could do that. Either way, you should get fairly quickly a distance of 900 meters. Remember, we're in mechanics, you need to put your units in. And that's full marks. I'll do that question, just the part B, once more, because again, a lot of students might have forgotten this area thing. Another way to think of this would be to split this up into 3 worlds. I would say 1, 2, and 3, and find the distance travelled in all 3 of them. This guy was already world 1. You just want to find out what S is. You have everything else, so you have a few options here. I would use U plus V over 2 times T, isn't it? Yeah, T. That's 0 plus 20 is 20. 20 divided by 2 is 10. 10 times 10 is 100. So that's the distance travelled in this world. Again, the area of this triangle is also 100. The second world, let me just write out all the things for units of equations of motion. U would equal 20 at this, V would equal 20, A would equal 0, I guess, T is equal 30. What's S equal? Again, you have a few choices to use, but once again, this is probably the easiest one. Starting velocity plus ending velocity is 40, 40 over 2, multiplied by the time. 30 is 20 times 30, that's 600. Again, that's the area of this rectangle as well. And finally, the third world would be use 20, the starting velocity. The ending velocity is 0. A, we don't know it. T is 20. Once again, we didn't need A for this, so once again, S is 20 times 0, 20 plus 0, 20, divided by 2, multiplied by another 20. So that's 200. These are all meters. 200 plus 600 plus 100 is 900 meters. Full marks again. Okay, that's it for question 1. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a great day.